Have you ever wondered what makes your phone light up or what powers the refrigerator that keeps your food fresh? The answer lies in something we utilize every day, yet often take for granted: electric current. Electric current is the flow of electric charge. It's like a river, but instead of water, it's filled with electrons. These electrons move from one place to another, creating a flow that we harness to power our daily lives. Now, one might ask, how do we measure this flow? The answer is in ampere, named after the French scientist André-Marie Ampère. It's often shortened to amps, and it measures the amount of electric charge flowing per second. But here's a twist. While we think of electricity as flowing from positive to negative, the direction of current is actually defined as the direction in which positive charges flow. This is a legacy from the early days of electricity, when scientists believed that positive charges were the ones moving. Now, all of this talk about flow and direction brings us to a fundamental law in the world of electricity: Ohm's law. Named after the German physicist Georg Ohm, it's a rule that helps us understand how voltage, current, and resistance are related. Imagine a garden hose. The water pressure is like the voltage, the flow of water is the current, and any blockages in the hose represent resistance. Ohm's law states that the current is directly proportional to the voltage and inversely proportional to the resistance. In other words, if you increase the voltage or water pressure, the current will increase. If you increase the resistance or blockages, the current will decrease. So, to wrap up, electric current is the flow of electric charge measured in amps. It's defined as flowing from positive to negative, though in reality, electrons flow from negative to positive. And finally, Ohm's law ties it all together by explaining the relationship between voltage, current, and resistance. Understanding these basics of electric current not only demystifies the power that lights up our world, but also sets the foundation for exploring more complex topics in electricity.